and welcome to space, folks. Welcome to the smAsho Cosmology segment, and thanks for tuning in. Let me first start by stating, when referring to space and everything in space, perspective is super important. Let me do a quick little demonstration for you here. So I've got this little disco ball. It's a floating disco ball for your pool. And I would note how vastly different this looks when you're viewing it from the side versus when you're viewing it from straight on. Notice how bright it suddenly gets? Well, we've got similar kind of stuff to this in space. And what I mean is our perspective in the Milky Way galaxy. So Milky Way galaxy team for the win. You are here with respect to the galactic core, and you can see that tab right there saying we are here. And basically the sun is moving through the Milky Way galaxy at about a 90-degree angle with respect to where the core is located. Now, when talking about galactic perspectives, from a galaxy that you're in, there is a shadow created by all the dust and gas and stars in the center of the Milky Way galaxy. And so we have to guess what it really looks like as we're viewing it from the edge. Again, somewhere out here in the Sagittarius arm, it's very difficult to see. In fact, it's impossible to see what is on the other side of the galactic core. Now, when viewing an object like a blazar, or any massive radio source, they tend to have jets coming out of their poloidal fields. When you view these down the jet, they look very bright and very difficult to measure. When you view them from the side, the gas and dust orbiting these objects in their toroidal field tends to obscure them. And that is the case from our perspective with respect to Sagittarius A star, the core of the galaxy. Now, just to zoom in on this a little bit here, this is what we call the local chimney, and this is the scenario right around where the sun is located. You can see at the bottom of the image there, it says galactic center to the right. And so we're really at like about a 60-degree angle with respect to where the galactic center is located. And the sun is moving away from Sirius. So an easy way to understand it, to visualize it when you look in the night sky, go out, find Sirius, and the sun is moving in the opposite direction to that. So if you imagine the sun on one side and Sirius on the other, that's the direction it's moving. And let's go back to the Milky Way perspective. That means that out here in the Sagittarius arm, let's just say there's a lot of stuff in between us and the core of the galaxy, otherwise known as Sagittarius A star, the massive radio source there. And Sagittarius A star's poloidal fields are offset by a significant amount. We're not going to go too in depth into that in this video, but this is the perspective of what it looks like from where we are, looking toward the galactic core. You can see there's an arrow there citing where the Milky Way center is, and then out on the right side you can see the Crab pulsar and nebula, Vela pulsar, Dominga pulsar. The Cygnus arm is out here on the left, this bright area right there, that is the Cygnus arm, down which we are looking down the barrel of. Now, when referring to galactic perspective, there's something very important to understand here. I'm just going to take this green brush and I'm going to put a dot right here. All right? If the sun is located there and it's moving roughly in this direction, that is a very different scenario than if the sun is located, I don't know, say over here and moving in this direction. As you can see, there's a vastly different amount of dust and gas from the perspective of this to the perspective of this with respect to the galactic core. We do assume the shape of the Milky Way galaxy is a spiral. Some people think it's a barred spiral. Some people just think it's a regular spiral. But again, perspective is everything, because if you are in an area like this, out here right on the spiral arm, that is going to be a completely different scenario than if you're in between spiral arms and so on. And we're not going to go fully in depth into what we're talking about here. Let's just say galactic superwave is a term being thrown around the internet rather haphazardly these days. And let's just move on here and talk about the forum real quick. Thanks to all of the new forum members. We're nearly at 50 forum members now. So thanks everybody. Cheers. Check out the most. We have this the most section here, and we just put another object in there. We're going to have another one too. And the latest addition is Blazar 3C 454.3. And we're just kind of preparing everybody for our upcoming video here. We're going to be making one about the propagation of energy on the galactic scale soon. 3C 454.3 is the most luminous object ever imaged. So feel free to read all about that. We've left all the links to all of those areas. And there's the article from NASA about the record flare from Blazar 3C 454.3. And just to go back to perspective real quick for a minute, when we're talking about perspective, what we mean is that, once again, with a blazar, you're looking down the jet, which gives you a completely different image of if you're looking from the toroidal view, if you're looking down the toroidal field as opposed to down the poloidal field. It's a very different scenario. Let's talk about another the most. The fastest neutron star I'm aware of, it's RxJ 185635-3754. And you can see how far across the sky this thing went. I don't know the exact astrography of it, but somebody saw this and they said, what is going on there? And then they saw it again, and then they verified that it indeed was moving at this ridiculous speed. It is a speed similar to the solar wind. I believe it's around 600 kilometers per second. Don't quote me on it. The fastest known neutron star RX 185635-3754. Now let's talk about this space article here on SciTech Daily. Astronomers have found the secret ingredient to the universe's brightest explosions. Now, we've got a lot of spaced out viewers on our channel. So can anybody guess what it is? Anybody? Anybody? It's scrolling very slowly. And I'm allowing this to happen to give props to SciTech Daily and allow our viewers to just read the article if you like. What's needed, folks, is a binary system. Yes, that's right. And there are thousands of indications that this is some more new science. Binary systems seem to be required in order to have extremely powerful gamma ray bursts. And it's going to get even more interesting. So don't get bored. Anyway, gamma ray bursts are the most luminous events in the universe. And this article suggests we can only see 10 to 20%. I think it's probably more like 0.02% of them, but hey, there aren't that many poles pointed at you, folks. But this is another super interesting article. Too many cosmology articles coming out per day lately to even keep track of it. And so you just got to keep adding those cosmic tools to your cosmic toolbox and considering the implications of how they extrapolate into the rest of cosmology. It's pretty deep. And let's get this scrolled to the bottom here so I can continue on. We don't want the video to be too long. And let's talk about Pulsar J 2021 plus 4026. Now this is another very interesting pulsar, as we've discovered something about its rotation and output that are inversely proportional to each other. Check this out. It's one of the brightest radio-quiet gamma-ray pulsars. In October 2011, observations with Fermi revealed a sudden gamma-ray flux drop and a change of the observed flux over a timescale of less than a week, which made it the first known variable gamma-ray pulsar. The researchers also found that the spin-down rate had changed. That's right, folks. When the gamma rays increase, the spin slows. And when the gamma rays decrease, the spin speeds up. So this is super important in terms of the behavior of pulsars. And we're not going to scroll this one. We're just going to tell you that we've put links to all of these articles. If you'd like to watch the transients of this particular pulsar, we link to that also. It's on the Neil Gorell Swift Bat Observatory. So feel free to follow the transients if you like, and we put a link to it also in Sinbad. And so that link is also there below the video. By the way, Twitch viewers, if you haven't seen our latest videos, if you'd like a aquarium screensaver, cast this to your big screen, and you can have 2 hours and 52 minutes of Jaws and Phelps in your living room or wherever you are. So check that out, twitch.com/smAsho. And by the way, don't forget to press like and subscribe on YouTube. And thanks to all of our new viewers. Let's put up a bonus feature here. Tony Heller's latest video about shrinking summers in North America. Let me just play a clip for you. As we've been seeing early falls and late springs for the last 3 years in the Northern Hemisphere, with record-breaking snowfall. Meanwhile, people are trying to sequester carbon dioxide out of the atmosphere and put a bunch of metal particles up in the stratosphere to block sunlight and cool the planet. Great idea. I think it's idiotic. What say you? Here's a clip.
Snow cover has gotten much larger over the last 50 years.
And indeed, the snow cover has increased in the fall over the past 50 years. Check out Tony Heller's page. Shout out to Tony. Nice job, up to 68,000. When we started following him, he only had about 13,000 subs. And thanks most of all to our patrons, the real source of funding for the channel. Please consider becoming a patron if you haven't done yet. And wait just till the end of this month, folks. We are going to have the 3C405 shirts. We'll have at least one to tease you, featuring Cygnus A massive radio galaxy, the second strongest radio source in the sky, second only to the local yellow dwarf. And thanks, Smash Team, here come the bonus features. And we're looking at the local yellow dwarf here in intensitygram to see if a sunspot is formed, and indeed it has not. There's that region in the north, and no sunspot there, just a plage. It is cycle 25 behavior. We're going to play the 48-hour video here and get out of here. Thanks for tuning into the Cosmology segment, folks. Please endeavor to understand the sun, as it is the Rosetta Stone of understanding the rest of cosmology. Don't forget to stare at the sun. And we will be back with more content coming soon. Thanks again, everybody. And this is Smash, signing off.